This session is led by Brian McDonald, our Director of Product Development, Roger Northrup, the Chief Technology Officer for Mutare, and also joining us today is our special guest, Janet O'Brien, Mutare's Chief Research Analyst. This is a session open for questions. Please type your questions in the GoToWebinar box or click on the question icon to pop out the type form. I will now turn you over to Brian. Good afternoon, Brian.
Good afternoon. Thank you, disembodied voice from beyond. Appreciate you. All right, welcome everyone, and thank you for attending our webinar, Cybersecurity for Enterprise Voice, protection from generative AI-based attacks. We're gonna have some fun today. All right, so brief agenda today. We're gonna give you guys an overview of generative AI. We're gonna talk a little bit about the threat that poses, and we're gonna give you a possible solution with the Mutare voice traffic filter, and then we'll end up with a little question and answer session. So let's dig right in, and let's talk a little about the difference between traditional AI and generative AI.
Yes, so traditional AI, Brian, it's been around for quite some time. It uses computational power and also a lot of data analysis. And this modeling is done against very large lakes, and it's about known information. All of us on the screen today, we know about the chatbots when we go to a website and it asks a question. That would be the traditional AI. Facial recognition on our iPhone, even voice recognition. Those are some of the traditional AI. Then you see targeted visual ads. This is ad tracking, which we all don't like, but it happens to us on the internet. And then also machine-based learning. That's a traditional AI. And Mutare's been doing this for a very long time already.
Thank you, Roger. Now, what's new is how AI has recently crossed, I'd say, like a threshold due to advanced computing power. Think about the new GPUs that are out and access to huge amounts of data. So you can create highly realistic and reliable machine-generated output, including things like text, audio, visuals, etc. And that's where generative AI comes in. But generative AI doesn't stick with what it knows, but it creates new things. It can create new text, new images, speech, code, designs. It's really, really cool.
You know, Brian, I was just going to say that I think a good analogy here would be to think of it like a chess game. We know that computer systems have been now taught to play chess. They've been programmed with the rules of the game. They can understand that the goal is checkmate. They've been fed all the data on all the possible counter move patterns and algorithms. And that allows them to quickly calculate and predict the best response to an opponent's actions. And they can do it faster than the human brain could do it. And that's classic AI. But with generative AI, the rules and the dependence on the historical data no longer matter, because GenAI moves beyond what it knows or what it's learned. And it would create an entirely new game of chess. It would be similar to the one it's modeled after, but entirely unique. Maybe even an improvement over the original game. And that's really the goal of generative AI applications. It's to be able to quickly generate something entirely new based on something familiar, but ideally better.
That's great. I love that. I love that analogy. Thank you. That's perfect. And when we talk about generative AI, you've all heard of things like ChatGPT, and that's doing more of a text-based generative AI. Things like DALL-E that can create images based on modeling. And what's really cool about generative AI is the possibilities in the future, right? So think of innovation, creativity, rapid prototyping. This can even speed application development. It can even output code. So think about how something like this can impact the healthcare industry, and imagine if it can create new tactics to prevent diseases or cancer. Really cool stuff. All right, let's now talk a little bit about the bad side of generative AI, and specifically the threat landscape. So what we want to talk about here is how generative AI can make things a lot easier for the bad guys. It absolutely can be used for bad, and it is currently being weaponized. One of the first things we'd like to talk about is an advanced persistent threat, otherwise known as APTs. And these are situations where a threat actor enters the network undetected and then remains there for a long period of time. Generative AI can find new vectors to attack, can be finding new avenues and new data, and can use its generative AI to actually create more chaos in there than a traditional type of attack.
Yeah, this is the one that kind of scares me the most, Brian, because it sits there, just waiting. Nobody knows it's there, and it's continually learning. So that's the part that is probably the most scariest about an APT.
Absolutely. And then the next thing we wanted to talk a little bit about is AI-powered malware. So if you can think about traditional malware, which is horrible, but malware that uses AI to think for itself is even scarier. So think about something that can adapt its course of action in response to the situation. It can avoid detection. It can avoid sometimes even countermeasures. This is other additionally very scary stuff.
Yeah, so looking at the next thing though is we're all very familiar with phishing, starting with a P. You get that email, it looks very convincing, and you just want to click on the link because usually it's a fear factor sometimes where they come at you. So they're very creative with that, and they it can reveal a lot of sensitive information. I think, Brian, you're going to talk a little bit about vishing in the next slide as well. So
very good. Yeah. The next one is deepfakes. We've all heard about these lately, and we've even seen some examples. And what deepfakes are is when AI creates something called synthetic media. So think of fake images, videos, audio recordings, and these are basically indistinguishable from the real ones. So these are used typically to impersonate people. Think about people in authority within an organization, CEO, IT staff, network administration. Threat actors then use these along with other social engineering techniques to gain initial access to the network. Just about a week or so ago, big in the news was a multinational company actually lost $25 million through this really intricate deepfake scam. Ultimately, this ended up being a video conference call where the bad guys used deepfake tech to impersonate the chief financial officer. And during that conference call, they convinced them to transfer the equivalent of $25 million. This occurred in Hong Kong. This is the type of scary stuff that's happening out there.
just amazing, just wow.
Crazy, crazy stuff. All right. So now, specifically, we want to talk a little bit about voice. So voice is a particularly vulnerable attack vector because it very much involves human interaction. And that's one of the weak points, especially when you're talking about security and you're talking about risk. With generative AI, things get really complicated. So some of the new tools are gathering intel. You can use AI to look for information about individuals, a company, and then get an entire landscape and create these new personas for an organization. So it's not just impersonating, but think about new personas. AI can then be used for scripting, and this scripting can be used for different conversation areas, different conversation directions based on what's happening. And then these imposters can use these generative AI models to not only write convincing scripts, not only do the research, but actually sound like the real person or a real person. Apparently, all a scammer needs is 3 seconds of actual audio from a person to be able to get a really good AI voice cloning created. Excuse me, very scary stuff. So to review the playbook, especially with voice, threat actors do the research. They can usually leverage contact centers. They call the contact centers. They can impersonate or create a new persona. And the goal there is to get initial access. And once they're in, their AI tools and models can actually go deeper.
Brian, can I interject here a second too? Because I wanted to mention that we're not talking about these lone actors, these individuals doing this. We're talking about highly sophisticated. They've morphed into these highly sophisticated, multi-billion dollar underground enterprises, complete with, they've got institutional hierarchies, they've got recruiters, they have HR departments, they have R&D budgets that they've funded basically through their cybercrime activities. And these funds are now being used to develop their own GenAI tools based on the easy access they now have to existing technology. And this is why the nefarious use of AI that you're mentioning before, Brian, that's why this is going to be very hard to regulate. Was it last week? I believe it was last week that the FCC passed a rule banning the use of people using AI-generated voice clones in unsolicited robocalls. And this is in response to the illicit Biden deepfake. Brian talked about the deepfake technology now taking 3 seconds of someone's voice and making a very realistic sounding voice. And there was a robocall incident that was
That's malarkey.
Yeah, exactly. You can probably look it up on YouTube if you want to, because it is surprisingly realistic. And it was during the New Hampshire primaries. And, the FCC would like to limit that type of activity, but I promise you it's not the first or the last time we're going to be hearing about something like this. It's a nice gesture by the FCC, but it's maybe it will deter some low-level ne'er-do-wells, but it's going to have very little impact on these very sophisticated underground criminal operations, because as we've learned, these guys are very good at evading detection. So I think I'm going to back off here and let Brian and Roger tell you a little more
Janet,
about.
thank you so much. And that chess analogy was killer.
Keep it. All right.
So to review here, the critical thing we're trying to get across here is generative AI makes vishing and vishing attacks just a lot easier for these threat actors. All right, so what can we do about it? And that's where we're going to talk a little bit about our voice traffic filter and what it can do to help organizations like yours. So our voice traffic filter, you can think of it as a firewall for your voice traffic. And we apply 5 distinct layers of protection. And within each layer are several countermeasures and analyses that occur. So we're going to talk about these for you just briefly. So the first one you see there is stir shaken, and we are not a stir shaken replacement. Instead, many of your carriers are already handling stir shaken, especially for US North American calls. So stir shaken data, if it comes across, we're giving you the power as the user to be able to choose what to do with that data. So you can choose, and when we say what to do, we offer you actions that you can take on the call. The most important and the most obvious one is allow. That's most of your calls. You're going to allow the call right through. But in certain circumstances, you may want to drop the call. Maybe this is a known fraud caller and you can simply just drop it. So that's another one. Another extremely powerful one is route, which means you can divert the call. Think about this from a security standpoint. This is going to be a quarantine. You might want to quarantine someone into a voicemail box where they can't get out and ask them some questions. For contact centers, a lot of times, this is set where you will route these calls to a skill group where you've got agents that are specially trained for suspicious callers. They're trained with all of the tools and all of the vishing techniques and social engineering techniques that might happen. But what you're doing is you're gaining knowledge, and that's really important. So back to our 5 layers. The next one is the proprietary dynamic database. This is Mutari's bespoke database. And think of this as a meta-analysis. The proprietary dynamic database is used by all of our customer, and it includes things like robocall lookups. It's got layers of protection inside it to do analysis on traffic patterns throughout the industry and throughout our customers. And we're able to feed that back to each of you to help you out. Consider it a continuous feedback loop. All right, Roger.
Yeah, I like that you talked about the first three, because a lot of those parts in Stir, Shake, and Proprietary and Threat Radar, that's where a lot of the machine learning, the algorithms that we use, and the heuristic pattern matching is taking place within the product. And that's all dynamic, okay, which is really fantastic. But the last two, the custom rules, this is where you as a customer has a lot of control to come in and make changes on the fly of being able to route a call, divert calls, and then send it to the next one, which is a voice CAPTCHA. So a lot of our customers get a ton of bot calls, and the CAPTCHA catches all of the bots because it does a reverse Turing test, a voice reverse Turing test, to make sure to challenge them before they can move on to the next leg of the call. So those are those two different rules that I really like to talk about.
You know, I think I skipped over Threat Radar. So
That's
I'm going to
okay.
come back. We're going to come back to Threat Radar. So back to the proprietary dynamic database, where that is a meta-analysis across all the customers. Think of Threat Radar as an analysis on your particular calling patterns. So as these spikes and ebbs and flows occur, we can be taking action based on those. So when anomalies occur, you can then direct the call in any fashion you'd like and make those decisions. And this includes technically machine learning, which isn't quite AI, but is in the same family. All right.
Yeah, Brian, I just want to make one more comment that all this is done very easily through a web interface. You don't have to understand any of the SBC information or command line structures. It's very well thought out.
Good, excellent. And I think we're going to see a little bit of that in a minute. So next slide here is where we want to show you of where we sit in the call, because a lot of people we talk to say, okay, that's really super, but how do we make this work? So if you take a look at a particular call flow here, and this might be a call flow for a contact center, it might be a call flow for any enterprise, you can see where we sit is right at the beginning of the call. So right here is where we sit here. And what that is right after the call comes in, before the call is answered, we're able to analyze the call, use our heuristics, and make a decision to feed downstream. So for instance, in a contact center, you might be doing a CRM lookup. In an enterprise, you might not, but you might be sending to an IVR or to somebody's desk phone, in which case it's all the same. We're either taking a look out on the front end and being that firewall for you, and even sometimes providing more data downstream. You'll see there are also some other, especially in a contact center, there's other types of security measures in place. So for instance, you've got authentication here. And if you're going to a contact center and going into the agent queue, a lot of times you'll have other products that are very good at detecting fraud while the call is occurring. And so you can see these all play very nicely together. But where Mutare sits is right on the front end of the call. All right. So let's show a little bit about that interface. This is probably one of the more useful pages that our administrators can access. And you can see it's very easy to understand here at the top. You've got taken a look at your call patterns throughout the week. In this case, I think we're looking at a couple months here, but you can see the call patterns day by day, week by week. And then in that middle section there, we're giving you the statistics you need. So we're showing you the number of wanted and unwanted calls. But more importantly, we're giving you information and deep information on all of those 5 layers of protection and how they are affecting the call. And then we can give you statistics on the most attacked numbers, your top callers that are wanted and unwanted. Now, behind this, obviously, are a bunch of other tools to allow you to go a little deeper on all of these. but this is a good example of the interface you're going to see here. All right. I see that there are a lot of questions, so we're going to move on. But first, our marketing team has required that we give you the following message. And that is, if you like today's session, you're going to love our next one. Register for our next 30-minute webinar with this QR code. In this next presentation, we'll cover the foundational best practices for voice security for 3 key business units: cybersecurity, information technology, and the contact center. And it looks like the bottom of that is cut off for some reason. So I'm going to swing this over here and tell you that it is Thursday, March 21st at 12 noon Central Time, or 1 o'clock Eastern. But I think that QR code will work for you if you want to take a picture using your cell phone. All right. So I think it's now time to move on to question and answer. It looks like we've got a bunch of questions on here. All right. First one. As most carriers do not share stir shaken between carriers, will your system still work? Absolutely. Remember, we've got those 5 layers of protection, and these all work in tandem. So if one doesn't work, no problem. The others will pick up the slack. It's not a problem. We have a lot of customers where the carrier doesn't provide all of the detail for stir shaken. Not a problem. All right, second question. Does this solution play well with Zoom phones and the Zoom phone environment? And Roger, thank you, Roger. I was going to say, you could probably help me with that one.
Yeah, we have partners that do provide Zoom services as well. They own the DIDs, and we're working with them with the integration points so that we're in the very front end of the call before it even gets over to the Zoom call. So yes, which you've seen today is implemented at that level.
All right. I think, am I seeing any other questions? I am not seeing any other questions. No other questions. All right then. So we will end it here. We thank you so much for attending our presentation, and we bid you all adieu and have a terrific Tuesday. Take care, everybody. Bye-bye.
Great. Thank you guys so much. I appreciate it. If you do have any additional questions, you can reach out to us at info@mutari.com, or a follow-up email will also be distributed today, and you're welcome to respond directly. Since we don't have any more questions, we're ending today's event. We do have a survey at the end. If you'd like to provide us some feedback on how we did today, we would appreciate it. Thank you so much for attending, and we hope we see you on March 21st for our next event. Thank you. Bye-bye.